confidence interval for proportions. A confidence interval is a range of values that estimate the population proportion. The process begins with finding the proportion from a sample of the population. So let's say that we wanted to know the percentage of all Cerritos College students who are veterans. So that means if we're looking for the percentage of all Cerritos College students, that means we're looking for P. P would represent the percentage of veterans in all of Cerritos College. So we want P, but we're probably not going to go survey every single student at Cerritos College. So instead, we sample 50 students and calculate the percentage of those 50 students who are veterans. So whatever percentage we come up with there, because it came from a sample, we're going to call that P hat. And P hat is our estimate for P. Estimate for the true population proportion. And that's how our confidence interval always begins. It always begins with your estimate from the sample, and we're trying to target our percentage for the population. Most likely, the sample proportion you get, P hat, will not be equal to the population proportion. There will be a sampling bias in the estimate, which we will consider by tacking on a margin of error. So your confidence interval starts with your P hat from your sample, and then we tack on and take off some error. So you get an upper bound of your confidence interval and a lower bound. Remember that the P hats are normally distributed with a mean of P and a standard error of the square root of PQ over N. That's everything under the square root. And remember, this is called standard error. And we usually abbreviate it SE. This is just the standard deviation of the sampling distribution of P hats. Now M is going to, your error is going to come from two things. Your error in the confidence interval is going to be based on what's called a critical value, and you're going to multiply that critical value times your standard error. So we already know how to get the standard error from this formula over here. And the critical value is going to come from your confidence level. And you can only get your critical value if some requirements are in place and you know that you have a normal distribution going on. So let's review the requirements for the sampling distribution of proportion to be able to be modeled with a z-distribution. First of all, the sample has to be a simple random sample, and that usually is going to be assumed for us because we're not usually collecting the data. The next requirement is that n times p, the number of successes, has to be bigger than or equal to 10, and then n times q, the number of failures, has to be bigger than or equal to 10. So you've got to check this. But remember, if you're estimating p, you're not going to know what p is. So usually when you check this, you're going to use p hat, which is your best estimate for p. The last requirement is that the population size has to be significantly greater than the sample size. So the population size must be bigger than or equal to 10 times the sample size. This usually works out in our problems just because our population sizes are so large. So when this happens, you know that your critical values can be found. Critical values can be found using the z-distribution. The normal distribution. And those critical values are going to tell us how many standard errors we need to move in order to get the certain amount of confidence that we want in our interval. So here's an example of a problem involving a confidence interval. The tobacco industry closely monitors all surveys that involve smoking. One survey showed that among 785 randomly selected subjects who completed 4 years of college, 18.3% smoke. So from that sentence there, I know that this 18.3% came from a sample of 785 randomly selected subjects. So my N must be 785, and my P hat, since it came from a sample, my P hat is 0.183, 18.3%. Then moving on in the problem, estimate the true percentage of smokers among all people who completed 4 years of college with 98% confidence. So this percentage here goes with my confidence level. So that 98% is my confidence level. Confidence level. It is not the percentage of smokers. We want to make sure we're very clear on that. And again, they give us one of our requirements right here, again, that we have a simple random sample. So let's remember what we have. We know that our sample size is 785. Our sample statistic, our proportion is 18.3%, and our confidence level is 98%. And keep in mind what you're trying to do. You're trying to estimate P, which is the population proportion of people with 4 years of college who smoke. So we know that our confidence interval is going to be P hat plus or minus some error. And we already have P hat, so let's start filling in that confidence interval. 0.8183 minus margin of error and 0.183 plus some margin of error. So all we have left to do is find out what our error is. And remember that we know that the margin of error is going to be the critical value times the standard error. Well, we already know that if we meet our requirements, we can find our standard error. So let's check our requirements to make sure that we know the central limit theorem is in place, and we can get a valid confidence interval. So our requirements are, first, we have to have a simple random sample. At the beginning, it said assume that it's a simple random sample. The second thing we have to check is that N times P is greater than or equal to 10, and N times Q has to be bigger than or equal to 10. Well, we could kill two birds with one stone. We don't know P, but we do know P hat, so we're going to use that to see if we meet this requirement. And if P hat is 0.183, then Q hat's going to be bigger than that. It's going to be around 82%. So we always check the smaller of the two, because if 18% of the sample is bigger than 10, then 82% of the sample is going to be bigger than 10. So let's check that requirement by checking N, which is 785 times 0.183. And I can easily see that this is going to be bigger than 10. You can find the actual value, but 20% of 785 is going to be pretty big. And 18 is somewhere near that. And then our last requirement is that the population size has to be bigger than or equal to 10 times the sample size. And our sample size is 785 students. So do you think that the number of people who have graduated with 4 years of college is bigger than 785? I think so. I think it's 10 times, at least 10 times that. So we are good to go with our central limit theorem. So it tells us a couple of things. It tells us that our critical values are going to be found using the Z distribution, because P hat will be normally distributed, centered on the true population proportion. And it also tells us that our standard error can be found. Our standard error is going to be the square root of P times Q over N. And again, we don't know P, so we'll just use our P hat estimate to find that standard error. So here we are at, so far this is our confidence interval, and now that we know the central limit theorem takes place, I know that my P hats have a standard error or standard deviation of 0.0138. So all I need now for my margin of error is my critical value, and I would multiply that by 0.0138. And since I know the P hats are normally distributed, I'm going to use the Z distribution to find my critical value. I've got my normal bell-shaped curve, and since I'm looking for a 98% confidence interval, I'm 98% confident that my sample data is coming from that middle of that bell-shaped curve. So my critical values are going to be here and here. So to find my critical value, and again, this is a Z distribution, my critical value is going to be inverse norm. And my area to the left, if I just do this, the lower critical value here, my area to the left, if I've got 98 inside, then that means on the outside, I'm going to have both of these are 2%, and so this one on the left side will be 1%. And so I'm going to do inverse norm, 0.01, and I get a critical value of 2.33. So now that tells me from my sample statistic that I need to pull my margin of error, I need to make it at least 2.33 standard errors in order to capture the population proportion. And that value is 0.032. So that's how many percentage points I need to give myself on error from that original estimate of 18.3. So after all that, we get a confidence interval that ranges from 15.1% to 21.5% for our, that's our estimate for the population of people with 4 years of college who smoke. So let's take it a step further, and suppose a report comes out that claims that less than 15% of people with 4 years of college smoke. Does our confidence interval support this claim or not? And so if you look at the number line, 15%, 0.151 would be here, and then 0.215 would be here. And then 15%, they're saying less than 15%. So 15% would be just shy of that 0.151, and it would be to the left of that. Notice it does not fall. This is our confidence interval right here. And so their claim is outside of our confidence interval. And so we would not support their claim. We would not support their claim because we think that actually it's a higher percentage of college student, of people with 4 years of college who smoke.